Right, in this video, we're going to talk about section 10-2 in chapter 10 that deals with data analysis and statistics. And we're just going to be looking at an introduction to data analysis and statistics. One of the things that is discussed in a course in statistics or in the topic of statistics would be displaying data. So this is the basis of section 10-2. And there is a part 1 to displaying data. As indicated in the textbook, there's also a part 2 as well. Okay, so in part 1 of displaying data, we're going to talk about constructing and interpreting pictograms, dot plots, stem and leaf plots, histograms, bar graphs, and circle graphs. Also, we'll use more than one type of graph to represent data. All right, so once data has been collected, their organization and visual illustrations are important. Such visualizations or graphs take many formats like pictographs, circle graphs or pie charts, dot plots or line plots, scatter plots, stem and leaf plots, box plots, or another name for box and whisker plot, frequency tables, histograms, bar graphs, and frequency polygons or line graphs. Okay, so basically a graph is just a picture that displays data. And graphs are used to tell a story. So we can pretty much look at a graph, probably answer some questions about it, and then try to conjure up a story about that particular graph. All right, so now let's look at some definitions here. We'll start you off with data analysis. This is a relatively new term that's used in mathematics, and it refers to a more informal approach to statistics because that's basically what statistics is. Part of it is just analyzing data. You're going to collect data and then do some type of analysis from that data to try to come up with a conclusion from it. Now, statistics as a whole is once referred to numerical information about state or political territories. Now, statistics is used pretty much in every aspect, like in the field of education, the field of social behavioral sciences, in science. It comes from the Latin statisticus, meaning of the state. Okay, so here much of statistics involve making sense of data. Now, what is data? Or what are data? There are observations such as measurements, genders, survey responses that have been collected. Okay, so pretty much when people conduct surveys of something, they want you to answer questions or choose answers based on that survey, and then they take your responses and everybody else's responses and try to make an analysis of that. Statisticians often collect data from small portions of a large group in order to determine information about the group. This information is being used to make conjectures about the entire group. All right, the reason for that most statisticians do that because it's impossible to take pretty much survey every single individual in the United States of America. So like if I want to take a survey of those students that take college algebra across the state of Arkansas, it probably would be very impossible for me to survey every single student in the state of Arkansas that takes college algebra because of the time and probably money. However, what I can do is use a small portion of a large group, and we usually call that a sample. If we deal with the whole thing in general, then it will be a population, but usually a sample, what it does is it's going to be a small group of a small portion of a large group. And I can do a survey there, survey those, and then analyze the data and make a conjecture or a conclusion about the entire population. Okay, describing data frequently involves reading information from graphical displays, tables, lists, and so on. Okay, so next we'll look at the two types or three types of data. Actually, there are two. One is categorical and the other one is numerical data. All right, categorical data is just data that represents the characteristics of objects or individuals in groups or categories, such as black or white, inside or outside, or if you're dealing with someone in college, it could be freshman, sophomore, junior, senior. That would be categorical data. Or in K-12, you probably deal with first grade, second grade, third grade, and so on, or male, female. Those are categorical data. Numerical data is just data collected on numerical values. So in grade school, students may ask whether there is a difference in the distance that girls and boys can jump. The distance jump is the numerical variable, and the collected data would be numerical. Or students' heights, that's numerical. Ordinal data combines the two, numerical and categorical data. So data may fit into categories, but numbers are placed on the categories, but numbers placed on those categories have meaning. Like, for example, the rating of a candidate on a scale from 0, meaning the lowest, to 5, which is the highest. And some survey responses have like numbers on it, which is pretty much categorized in a way from 0 to 5, let's say, for example, or from 1 to 5. Okay. Being not at all to most likely would be an example of something that's on a survey with categories in it. You might find the numbers there on those categories, but those numbers placed on those categories do have meaning. All right, the first type of graph we'd look at is a pictograph. A pictograph is used to represent tallies of categories. Like, for example, categorical data may be seen in determining the month that the most automobiles were sold. The month is a category. A symbol or an icon is used to represent a quantity of items. Here, a symbol or an icon is used to represent a quantity of items. A legend tells what the symbol represents. So like in this example of a pictograph that we see here for recycled newspapers, here they give you that each whole newspaper or the whole picture of the newspaper represents 10 kilograms. So here, these are the months. Now, for like December, if I see 3 of these, that means there were 30 kilograms of newspapers that were recycled for that month. And sometimes you might see a portion of a newspaper in the pictograph. That happens sometimes. All right, so now if I look at example number 1, dealing with the pictogram or pictograph, here you're going to choose a pictograph to represent the categorical data in the table to the right. And we're going to use the symbol of a glass to represent 10 glasses of lemonade sold. So here is the chart or the table with the glasses of lemonade sold for each weekday, Monday through Friday, and the tally, and then the frequency. So pretty much you'll have to choose which one of these would best fit the that table that you see it there at the top. And by looking at it, it will have to be, in this case, answer choice D. Because notice the frequency is 15, so you have one whole picture of a glass that represents 10 and half of a glass to represent 5. Okay. And then for Tuesday, half a glass represents 5. Wednesday, 1 glass, and then half of that glass represents 15. For Thursday, the whole glass represents 10, and then Friday, half the glass represents 5. So this answer choice right here will be the best pictograph for this situation. Okay. All right, next we'll look at dot plots. A dot plot or a line plot provides a quick and simple way of organizing numerical data. They are typically used when there is only one group of data with fewer than 50 values. So pretty much with fewer than 50 values, it'd be best to use a dot plot. Okay, now on the next page, say we had this. Suppose that 30 students in Abel's class received the following test scores, and these are the test scores that you see here. There are 30 of them. A dot plot for the class scores consists of a horizontal number line on which each score is denoted by a dot or an X above the corresponding number line value. The number of X's above each score indicates how many times each score occurred. So in this case here, here's that number line right here from, let's say from 50 to 100. And here they've went ahead and put X's on top of each number where that student received that corresponding score. So this is what the dot plot looks like. Sometimes they use dots as well. Okay, now based on that, we can identify some things here like this. Like two students scored a 72. So you see two X's there. That represents two students with a score of 72. And then you see four students scoring 82. There are four X's on top of each other. And there's a gap between the scores 88 and 97. Here's the gap right there. And then you have a cluster where a lot of test scores are there. So here, scores 97 and 98 form a cluster. And then there's one test score that is way out there from all the other test scores that you see here. We call that an outlier. So when I've gone over just some of these definitions here that you see here. So in this case here, an outlier is a data point whose value is significantly greater than or less than other values. So this is far away from all the other data values here. Now, later on, we will be talking about finding outliers and how to determine whether a data point is an outlier. And of course, a cluster is an isolated group of points. Here's that cluster right there, the isolated group by itself. And then there's a gap, the large space between those data points. So there's that gap right there. And of course, when we get into talking about measures of central tendency, we're going to talk about this term right here, the mode. That's the data value or the data values that occur the most. So if we look at this data, well, this dot plot, you see that there are 4 dots above the score of 82. That would be the mode because more people scored an 82 on that test than any other test scores that you see. All right, next we'll look at this example right here. Suppose we have 6 grade students reported the number of apps that they, well, 6th grade students, I should say, reported the number of apps that they downloaded to their smartphone. Construct a dot plot from the results given to the right. So here it is. Here is that data set right there. And we want to create a dot plot for this. All right, so what I'm going to do here is draw a number line. And I'm going to look at the data. We're going from 0 up to, let's say, 25. So All right, so here's my number line. So in this case here, let's see, here's on 0. I'm gonna do this in increments of 5. So it'll be 5, 10, 15, 20, up to, I think, 25. Okay, and then because we have to account for every data value here. All right, so this is where we do the dot plots. All right, I'm gonna start column by column from 11 to 0, 8, and 0. So here, 11 would be this dot here. Then the 2 would be here. 0 would be here. And then 8 would be here. So I put a dot there, and 0. I'm gonna put a dot above the dot for that 0, okay? So now for the next column, for the 6, that's next to the 5, so that dot goes there. 0 will have another dot above the other 2. A 1 would be here. 7, 6, 7 would be here. And 0 will be up here. And then for the next column here, 6 would be above this 6. Number 11, the 11 would be above, another dot would be above the other dot for 11. And then 15 would be here. And then 11 and 11 again, so I need 2 more dots. Okay, next column would be a 1. So I put a dot, a second dot above the 1. And then a 10 will have a dot there. 18 will have a dot here. 11. So we have another dot for the 11. And 13 will have a dot here. And then finally, this last column, a 1, there's a dot go in there. A 10 will have another dot above that one. A 25 would be this dot right here. And 11 will have another dot there, and 0. Okay, so that is what the dot plot looks like. So pretty much from that, you can find out that 25 might be an outlier, okay? But there is a way that we can find out whether this number 25, is an outlier. We'll talk about that in section 10.4. I can see here that the most frequent numbers, the ones that have the most dots, are at 0 and at 11. Okay, that's what we call the mode. Some cases you may have more than one mode, or you might not have no mode at all. Again, that will be discussed in section 10.4. Okay, but this is how we draw the dot plot for this situation. All right, next we have what they call a stem and leaf plot. A stem and leaf plot is similar to the dot plot, but the number line is usually going to be vertical, and digits are used rather than X's. Okay. So in this case here, for the scores of Abel's class that we talked about earlier, so here's that data set that we used in the example. We can take that and create this stem and leaf plot. And in a stem and leaf plot, on the left-hand side of your stems, they're usually going to be the first digits in each of those numbers. Your leaves are going to be the last digits of each number. And of course, in a stem and leaf plot, you must account for every single digit or every single data value, even if the data value repeats. Okay, so this is what that stem and leaf plot looks like. And in an ordered stem and leaf plot, the data are in order from least to greatest on a given row. Now, there are advantages of using a stem and leaf plot. They are easily created by hand. And also they do not become unmanageable when volume of data is large. And in this case here, no data values are lost, okay? That means when you do a stem and leaf plot, you have to account for every single data value in that data set. Now, for the disadvantage of a stem and leaf plot is that we lose information. In other words, excuse me, in other words, we may know that a data value exists, but we cannot tell which one it is. In other words, you might know that, let's say in this stem and leaf plot, that 4 people have a score of 82, but you don't know which 4 scored the 82 on an exam. All right, now next we're going to look at this right here. This is an example of a stem and leaf plot. We're just going to answer some questions about it. In other words, the following stem and leaf plot gives the weights in pounds of all 15 students in the Algebra 1 class at East Junior High. And here is that stem and leaf plot. Well, yes, stem and leaf plot right there. Now we're going to use that to answer these questions, like in part A. Write the weights of the 15 students. Write the weights of the 15 students. So in this case here, and they tell you, they do give you a legend with a 10 with a slash and then 3 that represents the number 103. So like for the 7, that's 70, and then each stem represents a number in the 70s. So this is going to be 74 and 78. And then for the 80s, this 8 represents the 80s. You got 83 and another 83. And then 85, 86, and 87. And then for the 90s, the 4 after that bar represents 94. And then 96. Then you got another 96, and then 98. And then for the 10, that represents 100. So this is going to be 104 and 108. All right, for the 11, there are no stems, no leaves after the 11. There is for 12, that represents 120. So you got 124 and 127. All right, so those are the weights of the 15 students written out. Now part B, what is the weight of the lightest person in the class? The lightest person, that means the smallest number. In this case, 74. And in part C, what is the weight of the heaviest person in the class? That's the highest number. That's going to be 127. Okay. All right, now I'm going to come back to part D a little bit later in this video, so I'll be back to that shortly. All right. All right, so now let's talk about how can we construct a stem and leaf plot. Here's how we can do that. Here we're going to find the high and low values of the data. That's number 1. The highest data value and the lowest data value. And then number 2, decide on your stems. Usually, if you have like 2-digit numbers, usually the first digit in that number will be your stem, the last digit will be your leaf. And then number 3, list the stems in the column from least to greatest. And then use each piece of data to create leaves to the right of the stems on the appropriate rows. And then next, if the plot is to be ordered, then we list the leaves in order from least to greatest. And then add a legend identifying the values represented by the stems and leaves, and then add a title explaining what the graph is about. Okay, so in this example here that we have, let's say a company employs 20 people whose age are listed on the right. And here we're going to answer the following questions from the information given on the list. So starting with part A, we're going to draw a stem and leaf plot for the data and then choose the correct answer. Well, actually, we'll just draw a stem and leaf plot. So in this case, what we need to do is draw a vertical bar because that's what we're going to have to do here for a stem and leaf plot. And then, let's see, let's find out what the lowest data value is. The lowest data value here in this case is going to be 21. And the highest data value, by looking at this, will have to be 64. So we're going from 20 up to 60. So our stem will start with a 2, and then 3, 4, 5, and 6. And then we add the leaves for each of those. So that 2 represents numbers that are in the 20s. And in this case here, you have 21, 29, and 24, and 22. Now, if we're going to put this in order, that means that the 21 will have to go first. So we need to put a 1 to represent 21. And then for 22 will be next. So a 2 will go here for 22. And then for 24, it'll be a 4. And for 29, you need a 9. Because here, these represents the leaves for the data values that are in the 20s. 21, 22, 24, 29. And now for the 3 representing the 30s. All right, let's find data values that are in the 30s, like 34. And another 34. That's it. So we have to write the 4 as a stem, as a leaf twice, because 34 occurs twice. In this case, you have to, for a stem and leaf plot, keep in mind you have to account for every single data value in that data set. So 34 has to have the 4 as your leaf twice. Now for the 40s. In this case here, I have 41, 42, 45, and that's it. All right, so the 41, I have a stem of, a leaf of a 1. 42, I had to write down the 2, and 45, write down the 5. And now for the 5, which represents the 50s, let's see, there's a 51, a 53, and a 55, and 59 twice. Okay, so in this case here, let's start by putting the 51 first, and then the 53 second, the 55 second, and then there are 2 59s, so I need to write the 9 twice. Okay, and then finally, the 60s. Let's see, 61, 62, 64, and 61. All right, so 61, there are 2 of those. I need to write down the 1 twice. And 62, then 64. Now I need to count my leaves. There must be 20 of them. So this is 6, 9, 14, 18. Well, I really messed up. And I think I know where I messed up here, right here. Okay, there should be a, let's see. I got 21, and then 22, 24, 25, 29, and another 25. Oh yeah, I really messed up. I had to have the 25 I left out the leaf of 5 twice. So let me do this. Put a 5 here, and then another 5, and then a 9. So this is 6, 8, 11, 16, 20. That's correct. Yeah. So you want to make sure that you account for every single data value. You want to make sure that if you have 20, a data set of 20, the leads have to be 20 in this case. So that's my stem and leaf plot for this data set. Now, are more employees in their 40s or in their 30s? As part B. Are more employees in their 40s or in their 30s? Well, their 30s, there are only 2 employees, and in their 40s, there are only 3. So that means there are more employees in their 40s than in their 50s, in their 30s. And then part C, how many employees are less than 30 years old? Well, if this 3 represents 30, anything less than 30 will have to be this right here, these numbers here. There are 6 data values where the employees are less than 30 years old. So the answer there will be 6. And then part D, what percentage of the people are 60 years or older? We have to look at the 60s right here. There are 4 data values with employees over 60 years or older. So we're going to do 4 divided by 20, and then times 100%. So if I do 4 divided by 20, I know that's going to be 0.2. 0.2 times 100% would be 20%. So 20% of the people are 60 years or older. Pretty much you just have to use your calculator to do 4 divided by 20 times 100, and then you'll get 20, and then you just have to add the percent sign behind it. Okay. All right, next we'll look at back-to-back stem and leaf plots. I just briefly talk about this, but sometimes back-to-back stem and leaf plots are sometimes used to compare 2 sets of related data. Let's say you want to compare test scores, one class to another class, like Mr. Abel's 2nd period class to Mr. Abel's 5th period class. Normally, if we do a back-to-back stem and leaf plot, the stems are in the middle. The leaves for one class will be on the left, the leaves for the other class will be on the right, and they do give you a legend for that. Now notice the stems on the leaves on the left are going to be going in numerical order from right to left, as you can see. For the other class, the leaves on the right is going to be from left to right, least to greatest. And a stem and leaf plot shows how wide a range of values the data cover, where the values are concentrated, whether the data has any symmetry, where gaps are in the data are, and whether any data points are decidedly different from the rest of the data. Okay, so pretty much you can paint a picture of what a stem and leaf plot tells us. All right, next we'll look at frequency tables. Frequency tables. Now here, a group frequency table shows how many times data occurs in a range. The data is summarized in groups divided into intervals called classes. So in this case here, if we were looking at the data for ages of President's death, here on the left-hand side, these are called classes because it is a range, and we call those classes. From 40 to 49, 50 to 59, 60 to 69, and so on. Those intervals are called classes. And then in the middle, you have your tally. You tally up how many presidents died at the age between 40 and 49, how many died at the age between 50 and 59, and so on. The frequency will be the number of tally marks from the center. And then the total will be the total number of presidents, 38, that have died. So that's what a frequency table looks like. All right. Now here's some characteristics of a frequency table. Each class interval has the same size. So if you look at this illustration here, the class size, well, the interval is from 40 to 49, that difference is 10. 50 to 59, that difference is 10, and so on. So you can see the class interval has the same size. The size of each interval can be computed by subtracting the lower endpoint from the higher endpoint and adding 1. So for 40 to 49, we subtract 40 from 49, that will give us 9, add 1 to the 49. Add 1 to the 9, you'll get 10. So that class size is 10. So the size of each of these intervals is 10. We know how many data values occur within a particular interval, but we do not know the particular data values themselves. Okay. And that's obvious here because you don't know what those data values are from that frequency table. You just know that, let's say, 12 presidents died at the ages between 60 and 69, but you don't know their actual ages. As the interval size increases, information can get lost. So you want to keep your interval size as small as possible. And then classes or intervals should not overlap. In other words, I can't have this saying 41 to 50, then from 50 to 59. That means there's going to be an overlap there. You can't have that. All right, on the next page is histograms and bar graphs. I'm going to end this video with histograms here, and on the next video, part 2, will be the start of bar graphs. A histogram is made up of adjoining rectangles or bars. Now the bars are all the same width. The scale on the vertical axis must be uniform. And a distinguishing feature between histograms and bar graphs is that there is no ordering that has to be done among the bars of the graphs, among the bars of the bar graph, whereas there is order for a histogram. Okay, and here's an example of that. Here, the order does matter because I have to start from 40 to 49, then 50 to 59, 60 to 69, and so on. Notice on the vertical axis, there is a uniform scale. The frequency is uniform from 0 up to 12. And also, as you can see, frequencies are shown by the heights of the bars, of the vertical bars, each having the same width. Okay. All right, now, there was an example 3 that I went over on this video, so I'm going to revisit that example 3 to construct a histogram of that stem and leaf plot. Okay, because here's a stem and leaf plot that I did, and we're going to draw a histogram from this. From this stem and leaf plot, we can construct a histogram. By the way, if I was to turn this paper over like this, you can see here that pretty much the stem and leaf plot can itself form a histogram. Okay, so now let's use that to construct that histogram. All right, so I'm going to draw my vertical axis and my horizontal axis like this. And it might help to do a frequency distribution or frequency table. I'll go ahead and do that as well. I'm just going to say weights of students and then frequency. And this is starting from 70 to 79, then 80 to 89, 90 to 99, 100 to 109, 110 to 119, 120 to 129. And that's coming from this stemmenly plot from 7 all the way up to 12, because 7 represents 70 to 79, the 8 represents 80 to 89, the 9 represents 90 to 99, and so on for those stems. Now let's count how many stems I have for each of, how many leaves I have for each of those stems. And you can look at this right here and determine how many data values you have between 70 and 79. In this case, there are 2 of them. So that frequency would be 2. For 80 to 89, as you can see, there are 1, 2, 3, 4, 5. Then for 90 to 99, there's 1, 2, 3, 4. From 100 to 109, there are only 2. From 110 to 119, there's 0. And then for 124 to 120 to 129, there are only 2. And of course, there were 15 students, and that means if I add 2 and 5, that's 9. 7 plus 4 is 11, 13, 15. So I have all 15 students here. So now, from this frequency distribution, I can go ahead and do the histogram. Let's see, the highest number is a 5, the smallest is 0. So this will be 0, 1, 2, 3, 4, 5. Let's see, the horizontal axis will be from 70 to 79, then 80 to 89, 90 to 99, 100 to 109, 110 to 119, and 120 to 129. All right, so here I'm going to be drawing bars that are next to each other. All right, so from 70 to 79, the frequency is only 2, so the height of that bar will be at 2. So here's the height of the bar at 2. So I'm going to draw a bar going this way, and then it's going to come down like this, 70 to 79. Then from 80 to 89, the height of that bar was a 5. So here I'm going to draw a vertical bar. The height will be at 5 like this. Then I'm going to try to come down. Now the bars have to be adjacent to each other. They got to be touching each other. So that's the height for 80 to 89. And then for 90 to 99, there was 4. So the height of that would be at 4. Coming this way and coming down this way. And then for 100 to 109, 100 to 109, there were only 2. So the height is at 2. Comes this way. I'm going to come down this way. All right, so for 110 to 119, there was 0. So we're not going to draw a bar for the range of 110 to 110 to 119, but for 120 to 129, the height would be at 2. Okay. So pretty much you can see the gap there between those two. All right, so that's how you construct a histogram from a set of data. Okay, and this was the continuation of part D of the example 3. Okay, so that's going to conclude part 1 of section 10-2 dealing with displaying data. Okay, the other part of that video will be available for you later, so be on the lookout for part 2 of this same section 10-2, displaying data part 1.